So again the unit is meter. Right. So for this distance, imagine this was also the x. So I am representing this x's for different purposes, time also and distance also. So when the disturbance has traveled x distance, I mean lambda distance, how much time it has taken? One time period. That is wavelength. So it is also this distance between when the vibration is going from one crest to another crest or from one compression to other compression. That time the disturbance travels how much? One wavelength. Okay. Likewise here also. It travels one wavelength between two consecutive rarefactions. So whatever time it takes for two rarefactions to form, in that time, one time period, one vibration is completed. In that time, the wave has also traveled how much? Wavelength. And this will always be constant. Okay? So this is how the wave is characterized. Through its amplitude, through its time period, through its frequency, through its wavelength. This is the identity of a wave. Any wave must have all this. Then it should also have speed. So wave speed. So wave speed is denoted as small v. See the difference in the symbol. Okay. So what is wave speed? It is the distance traveled by the wave in unit time. Okay. So that is. So how can you define v? Distance upon time. And we know that when the wave travels distance lambda, the time taken is one time period. So therefore wave speed must be lambda by t. Correct? And what is 1 by t? Frequency. Okay? So the speed of wave is given as product of its frequency and wavelength. So sometimes you may be asked to derive this formula. So you have to start in 3 steps you can get it. Okay. So with this we have completed the foundations of this topic. There are certain examples here. Okay. So all the numericals you can do by using these 3 formulas, this and this. Only these 3 formulas. So let's do one example now. Are you done with everything? Okay. What is example 1? Sound wave has a frequency of 2 kilohertz. Wavelength given is 45 centimeter. So distance given is 1.5 kilometer. How much time it will take to travel? 1.5 kilometer. Okay. Solution. So this you can write 2000 hertz. Convert everything in SI unit 0.35 meter. This is 1500 meter. Okay, 1.5 kilometer is 1.5. So since G is equal to S upon T, distance upon time, therefore time is equal to S upon V. So V is what? Speed of the wave. Okay, this is the general formula for speed. And then this is which speed? Speed of the wave. So I can write it as S upon mu lambda. Okay, is mu into lambda. So find out how much is the S? 1500. Mu is 2000. Lambda is 0.35. So solve it. This is 15. Again, these two zero will go up. So this is 5 sevens are 35. 2 into 7. 5 30. This is 15 by 7. 15 by 7 second. Okay. So 7 2s are 14. 7 1 7. 7. 2.14 second. So it will take roughly 2.14 seconds or 2.1 seconds. Next is characteristics. So there are three characteristics: loudness, pitch, third is quality. So following characteristics of sound waves help distinguish between different sounds. You understand why we need these characteristics? So different sounds will have different level of loudness, pitch and quality. So what is a loud sound? धीरे से बोलोगे तो less loud, जोर से चिल्लाओगे तो loud. Okay? So loud sound, loudness depends on amplitude of the sound. Loudness depends on amplitude. More amplitude means sound has more energy. Okay. Pitch depends on frequency. Okay. The quality depends on okay. Quality depends on source of the sound. Okay. So how do you use quality to differentiate between two sounds? There may be two sounds with same loudness and pitch, yet their quality will be different. For example, let us say three of you are speaking at the same loudness level and with same frequency, but yet you will sound different because different vocal cords, sources are like in chorus. Three singers are singing. Each singer will have his own voice, but they are playing or singing at the same loudness and same frequency in harmony. But yet their voices are different. Understood? So, like in an orchestra, different musical instruments are played at same frequency and same loudness. But you still know this is flute, this is tabla. Okay, you'll be able to distinguish because the sources are different. Is this clear now? So loudness में like if I am speaking, इधर आना, ये धीरे से बोलो, मैं जोर से बोलूँ, इधर आना, तो तुमको पता है नहीं बोलूँ, but in the first case amplitude is less, second case amplitude is more. But suppose the ear sensitivity is different. Even if I am shouting, some might feel it's a normal voice. So loudness is based on hearing perception. It depends on the listener's ear sensitivity. Same is the case with pitch. Some ears are tuned, better sensitive to different frequency. So it is these two are subjective quantity. These are experience based. These are experience based. So how do we measure this objectively? These are subjective characteristics. How do we measure it? So loudness is measured in what is called as intensity. Intensity. So how do we define intensity? Now it is a technical measurement of loudness, and that will be unique. Right? The same loud sound may be perceived differently by different listener, but intensity of the given loudness will be unique because it is scientific. So how it is defined? It is defined as sound energy passing. Let us say this is the area. Look here. When I am speaking, let's say this area of cross section. So sound energy passing through a unit area, 1 meter square per unit time. Sound energy or any kind of energy passing per unit area per unit time. This is how intensity is defined. So how much sound energy is passing per unit area, per unit time is called intensity of sound. Okay, and you know energy upon time is power. Okay, how much sound power is traveling per unit area. Okay, that's why unit of intensity is watt per meter square. Unit of intensity is watt per meter square or joules per second per meter square. Okay. Okay. Now, pitch is male has low pitch, low frequency. Male voice has low frequency. So female voice has higher frequency, right? So that's why male frequency sounds flat. Has low frequency or flat pitch. Okay, it is also mentioned referred to as flat pitch. Okay. So female voice has high pitch. Now frequency is frequency, it is measured in hertz. But the hearing sensitivity may be different. So when you want to measure pitch, you have to measure it in frequency. Right? Now, that's it. And quality, I told you what it is. Okay? Quality will have a different waveform. Sabka waveform alog hoga because source is different. Okay? So you can discriminate sound even by, without looking at the source through its quality. You know the characteristics of sound. I already told you speed of sound is different in different media. Right? Now, what is a note, tone, and a note? Let's also understand what is tone. Tone is a sound of single frequency. Unique or single frequency. Okay. So only a single person is speaking or singing. So that sound is a tone. And note is sound of mixed frequencies. So like a musical note. Sound of mixed frequency is called a note. These are different terms you might come across. So almost done. Next is reflection of sound.
So what is written here after unique?
Unique or single frequency. Now let's learn about reflection of sound. Are you familiar with reflection of light waves? Just like light wave, because sound is also a wave, right? It also obeys laws of reflection. Also obey laws of reflection. When it falls on any surface, okay, such as wall, right? Hill. So the reflecting surface should be large. Okay. So suppose this is the wall on which a sound wave is incident in this direction. This is angle of incidence. So angle of reflection. So angle I will be equal to angle R. So this is incident sound wave direction. And this is reflected sound. Okay. So angle of incidence will be equal to angle of reflection. This is law of reflection. And incident wave, reflected wave and the normal line in the same plane. Okay. That also is okay. Okay. So one of the application of reflection of sound wave is echo. Okay. Hence, have you heard your own echo? After the original sound ceases to exist, you hear your own sound. That is called echo. Right? So echo is example of reflection of sound. Is production of echo. What is echo? So, which is what is echo? Echo is when the reflected sound is heard after the original sound ceases to exist. Okay? When reflected sound is heard after the original sound ceases to exist, then echo is observed. Echo is observed. This is what echo. Okay? So why are we not listening to our own sound here? यहाँ पे wall तो है.
The objects, it's not completely empty.
So what? So is it not reflecting sound? These surfaces are reflecting all the time. It is because your sound Okay, vibration takes time, right? So the hearing sensation stays in your ear for about 0.1 second, 1/10 of the second. So when the echo reaches your ears after 1/10 of the second, only then you will hear it. Otherwise, the reflected sound gets mixed up with the original sound. What is written here? Original sound ceases to exist. Okay? Therefore, echo is heard distinctly when reflected sound reaches the listener after at least 0.1 second. This is the time of echo. The time of echo. Minimum time. The minimum time needed for echo. Okay? So sound persists in the ear of the speaker for about 0.1 second. तो अगर इतने इससे कम में रिफ्लेक्टेड साउंड आ गया तो हमको दो अलग अलग साउंड सुनाई नहीं देंगे. Got it? तो एको सुनने के लिए कम से कम 0.1 सेकंड के बाद पहुंचना चाहिए. ठीक है?
So why is the effect of echo more in empty spaces like a new room?
So in this empty room you will not hear echo. The room has to be big. So we are going to cover conditions of echo. The wall has to be certain distance away. The reflector should be some minimum distance away. So let us find the conditions for echo. Suppose this is the reflector of sound. This is the incident wave. Some speaker is here. So speaker and source, sound source. And here you have sound detector. Okay, so this could be ear, this could be mouth. Somebody is speaking. So when the reflected sound comes back, right? Imagine this distance is d from here to here. So sound is traveling d and coming back d. So what is the total distance traveled by sound? 2d, right? And the speed of sound is 344 meter per second. Okay. So what is the minimum distance for the echo to be heard? So distance is what? Distance upon time is speed. So distance is speed into time. Okay. So what is distance? This is 2d. D plus d must be equal to v into d. D for going, d for coming back. Therefore, d is equal to, in cases of echo, you have to use this formula. Minimum distance needed for echo to be heard should be this. So let's substitute. V is 344. Time is 0.1 second. Time of echo. divided by 2. Since T is equal to 0.17. So how much is this? 7. So to hear echo distinctly, the sound reflector should be at least 17.2 meters away. But इसके लिए यहाँ पे echo नहीं सुनेगा. But in big halls, big empty halls, cinema halls you don't hear echo because you have some provisions. अभी हम वही पढ़ने वाले हैं. Yes. Sound absorbing materials are put. Soft boards, curtains, all the furniture. So everything absorbs sound. So when I'm speaking, even this is vibrating. So it is absorbing energy. Therefore, the sound reflector should be at least 19.2 meters away for echo to be heard. Got it? So there is a cliff. Cliff is like some hillside, steep wall. And there is some observer. He claps. So he hears echo after. He hears echo after t equal to 2 seconds. What is the distance of the clip from the person? Let us say this is the distance. If the speed of sound is 346, what is the speed of sound? 346 meter per second. Okay, you have to find what is the distance of the cliff. Cliff is a hillside. Okay, so what is the formula? You will use this formula in all echo questions. This formula has to be used. So D is equal to V into T by 2. D is 346. T given is 2. It must be 346 meter. Okay, it has to be 346 meter. Right? So in the book they have first found 2D and then so once you know this formula very easily you can get. Okay? So for all echo questions you have to solve them. So some applications of reflections of sound we'll see now. Practical applications. So applications of reflection of sound. Okay. So in megaphones, मेगाफोन पता है क्या होता है? पब्लिक एड्रेस करते हैं ना, तो उसमें क्या होता है? ऐसा पकड़ के वो यहां से कोई बोलता है, सम पर्सन स्पीकिंग, ये साउंड क्या होता है? ऐसा जाके रिफ्लेक्ट होता है ना? यहां से साउंड आके ऐसा दूर तक जाता है। अब विदाउट मेगाफोन बोलोगे तो थोड़ा ही जाएगा, लेकिन इसमें मल्टीपल रिफ्लेक्शन होके दूर तक जाता है। वही चीज होती है तुम्हारी ट्रम्पेट्स में। इन ट्रम्पेट्स आल्सो यू हैव अ पाइप, कोनिकल पाइप। तो कोनिकल पाइप में साउंड तुम्हारा दूर तक जाएगा। अगर ये नहीं होगा तो ऐसे डिस्पर्स हो जाएगा, बहुत अलग, ऐसे फोकस वे में दूर तक जाएगा। ठीक है, तो मेगाफोन, ट्रम्पेट, शहनाई, और उसमें सब में you are able to forcing the sound to travel in a well directed direction, okay, due to multiple reflection, है ना? ऐसे होता है। तो हर जगह पे लॉ ऑफ रिफ्लेक्शन I इक्वल टू आर होता है हर सरफेस में। जहां जहां रिफ्लेक्शन हो रहा है क्या हो रहा है? I इक्वल टू आर। ठीक है, सो इट गाइड्स द वेव इन फॉरवर्ड डायरेक्शन। तो ये हो गया। दूसरा स्टेथोस्कोप, डॉक्टर का जो स्टेथोस्कोप होता है, मेगाफोन, trumpet, etc. स्टेथोस्कोप, इसमें क्या होता है? So doctor has two sound inputs, इसके ईयर में जाता है। ठीक है, this goes into the ears of the doctor, and how he picks sound? So he has something, some object he places on patient's chest. ठीक है, तो चेस्ट पे, चेस्ट कहाँ चला गया ज्यादा, ऐसे ऐसे, ठीक, so it will pick up vibration and then those vibration will multiply reflect और फिर उसके ear में पहुंचेगा ऐसे। ठीक है, so this is how it pick up vibration and stethoscope में जाएगा, multiple reflection हो रहे हैं, दोनों तरफ जाएंगे। ठीक, फिर और क्या है? Ceilings of concert hall and cinema hall are curved. So you can see the diagram in the book. When the ceiling is curved, so audiences, sound will be evenly reflected to even the last row of the audience. Okay? So ये तो vertical हो गया। वैसे जो स्टेज है, स्टेज उसको भी कर्व्ड बनाएंगे। समझे, यहाँ पे परफॉर्मेंस चल रहा है, ये स्टेज कैसे? ऐसे ऐसे, यहाँ पे पर्सन इज परफॉर्मिंग एंड ऑडियंसेस आर सिटिंग इन फ्रंट ऑफ हिम, वो पूरा फोकस करेगा आगे। ठीक है, सो द स्टेज इज आल्सो कर्व्ड एंड द सीलिंग इज आल्सो कर्व्ड। ठीक है, फॉर यूनिफॉर्म डिस्ट्रीब्यूशन ऑफ साउंड। ठीक है, अब लास्ट, ऑलमोस्ट वी आर रीचिंग द लास्ट टॉपिक। Understood the multiple reflection? This is theoretical. Okay. Then we have range of sound. So you have audible range. To human is all the frequencies from 20 Hz to 20 kilohertz. Humans can only detect sound in this range. We cannot hear sound below this frequency or above this frequency. But there are sound waves which can be detected by animals. Bats, right? So you have frequency greater than 20 kilohertz. That range is called ultrasonic. Okay, these are called ultrasonic waves, ultrasonic sound waves, or just ultrasonic. And less than 20 is called infrasonics. So this is less than 20. So humans can only hear this. All sound waves have same speed. Okay, all three travel with the same speed because they are all sound waves. But humans can catch only this frequency. It's called the audible range. Sometimes it is referred to as sonic. Just sonic. So sonic wave, ultrasonic wave, and infrasonic. This is how it is characterized. All three travel with same speed. So what about energy? Energy depends on frequency. So highest energy is ultrasonic. Okay, ultrasonic or ultrasound or ultrasound. So this has highest energy. This has least energy. This has moderate energy. So जिसका जो sound का frequency ज़्यादा उसका energy highest. ठीक है? So that's why it has lot of application. Ultrasound का हम बहुत सारा industrial, medical, communication दो तीन applications है. So what animals can hear infrasonics? So elephants, whales, bats. So bats and dogs. Okay, newborn kids also. So as we age, our ear sensitivity decreases. So newborn child have got better ear sensitivity. And you can read some more things when you read the textbooks. Yeah. So how is the pace? Is it little fast today? Or is it okay? Is it going in the head or above head? It's interesting topic, not very difficult. Okay. So okay. Then uses of ultrasound. So there are certain applications, ultrasound, uses of ultrasound. So it has industrial uses, medical uses. Okay, these are the two types of uses. So what are the on the industrial side? We have cleaning of so it is used to detect Flaws. Flaws as in welding or cracks in metal blocks. ठीक है? So basically what happens, suppose
buildings.
huh?
Buildings or buildings.
Just check the spelling. Welding it is written, whatever it is. Welding means joining two iron pieces, okay? So basically what happens, whether the welding is proper or is there any gap, right? So what happens is, let us say this is a big metal blocks used in construction, etc. And it has a cavity inside, which is not visible from outside. It is supposed to be a solid metal block, but inside there is a cavity. So when you pass ultrasound waves, right? Let's say, so in the detector, you transmitted from three sources ultrasound wave, right? So these detectors are transmitter and detector together. Okay. So wherever it finds cavity, okay, it will not pass further. It will be reflected away. So here you will come to know that all the sent ultrasound wave have not reached here. Understood? So this is how ultrasound waves can be used for industrial usage. Then it is also used for cleaning small machine parts like watch or electronic components. Okay. So what you do is such small machine parts. So there is a detergent or some solution, cleaning solution is there. In that the components are put, and then the ultrasound waves are passed through the solution. So it vibrates the solution, and thus the dust gets detached. So small components or like odd component which you can't really physically do, so you can do cleaning with the help of ultrasound. You have the cleaning solution, put the components, pass ultrasound wave in the solution, it does like a washing machine, clean. Okay? So that's what it is. Two plastic surfaces can also be welded together when they are subjected to ultrasound. So this is also there. Then in the medical field, you must have heard about ultrasonography. So what do you do? Ultrasonography, why do you use it for? You use it to image the internal organs. How do I see my liver, gallbladder, right? Uterus in females, and then pancreas, all the internal organs, heart, right? Status of the babies in pregnant women. So all that can be seen with the help of ultrasonic waves. How? These waves are directed and the reflected waves are analyzed on computer. And the image is generated from the information received by the reflected ultrasound wave. So there are techniques using which image can be constructed. Virtual image can be constructed. So without cutting, the organ's status can be figured out. Okay. So this is ultrasonography. When it is specifically used for heart imaging, then it is called echocardiograph. Okay? So all of it is given here. Okay? So ultrasonography is used for heart disease, all that. Okay? So for imaging of internal organs and their live status can be seen on the monitor. So the input is coming in real time and it is processed by computer in real time, and the image is also produced in real time while the patient is sitting. So like a stethoscope, such kind of probes are put and they will get input and the monitor will show actual status of the internal organs. Okay? So this is it. This is all we have from sound, and I've already solved two examples. So those formulas only will be used. Okay, so let us take some classwork numericals. I will just take up. We have how much? 5 minutes more, I think. 5-7 minutes. Let's see how many we can do. So this was a very small and easy chapter. So where are so classwork numericals I will do. Okay. So So first question, come on page 76 everyone. So this is a easy chapter, but not conceptually. If you know the concept, then easier. Otherwise, it will give you a headache. So those who are not present, they're going to get a headache. Okay? So help them. Share the notes and advise them to go through the video. Okay? And if required, I'm there for helping. Okay? So just do that to your friends. So first question, what is the amplitude in the given wave? Look at the wave and tell me.
Plus 2z.
Yeah. 2 centimeter. You said 2 centimeter. Plus minus. Okay. Then a sound wave has frequency 5 Hz and wavelength 20 centimeter. How long will it take to travel 1 kilometer? So what it will be? Which formula? Time you have to find out. Time will be distance upon velocity. And then wave formula. Right? So 5 Hz, wavelength is 20 centimeter. And distance is 1 kilometer. So distance is 1000 meter. This is 5 Hz. And how much is the lambda? 20 centimeter is 0.2 meter. So this is it. So 5 to the 10, it will be 1000. It will take 1000 seconds. Okay? So it will take 1000 seconds. So V equal to 1 meter per second बोलेंगे उसका आंसर क्या है 1000 सेकंड वो कुछ डिफरेंट है यार अलग आंसर मिक्स हो गया now question 3 में क्या है so echo is returned in 1.5 seconds so this is time of echo right what is the distance of the reflecting surface from the source the speed of sound is 342 so I told you in echo question V is equal to V into T by 2 use करें So now you solve it yourself. Question 4. I'll give you the formulas for every question. A person stood near a cliff and clapped. We heard the echo of the tree. So echo time is given. Again the same thing. Same formula. Do the unit conversion properly. Here also you have to find T only for this. Now sonar, okay, sonar is one thing I forgot to tell you. What is sonar? Right? One of the applications of ultrasound wave is sonar also. Right? So what is sonar? It stands for sound navigation and ranging. Okay, so sound, navigation and ranging. It is used by animals such as bats. Bats use it because bats can't see. Bats can't see. Okay, but they produce ultrasound waves. So let's say you have a bat here. So let us say here it has a prey. So it is sending ultrasound waves in all directions. And here let us say there is some rock or hill. So it is sending wave in this direction. Everywhere sound wave goes in all directions. So the reflected sound wave from the nature of reflected sound wave, right? Bat will be able to figure out whether it is safe to travel in this direction. So judging the direction is called navigation. Safe direction to travel. And ranging is, it will be able to estimate the distance. Estimation of distance is called ranging. Okay. Navigation is about direction. Ranging is about estimation of distance. So this could be a prey, okay, and this could be an obstacle. So through sonar, sound navigation and ranging, it is basically a reflected sound. Sound navigation. So through the reflected sound information, the bat will be able to judge whether it is safe to fly in that direction or not. So it will change the direction because it can't see. And if it is a prey, so it will continue to go and hunt it. Okay? Same is followed by dolphins in water. Dolphins also send this kind of, they apply sonar. And it can be also used by ship, like fishing trawler. Or during sailing, find the sea depth. So in the ship, you have a sonar device. So sonar device is both ultrasound transmitter and ultrasound receiver. So you can actually, people can actually figure out the sea depth. So in this, they have provision to measure the time. So this is D, going D and coming D, reflected sound. So they can measure the time. This sonar device can tell how much time it took for the sound to reflect. And then they can use this formula to calculate the sea depth. So this is ranging, estimation of distance. यही तो ranging है. Okay? And if they are living beings, like if the ship is sailing ahead and there is a tip of the iceberg. This is the tip of iceberg. So whether it is safe to travel in this direction or not, they will be, so sonar device will receive the signals back. So it is sent in all directions. तो ऊपर से टिप छोटा सा दिख रहा है, but it might be widely spread, and which is not visible. So then the captain can take a decision whether it is safe to travel in this direction or not. So judging the direction is called navigation, and estimating the distance is called ranging. So this is the formula for both navigation and ranging. Is that clear? ये चीज radar होता है, radar. So the speed here it is ultrasound, sound wave. It is traveling very slow. But in military application, we don't use sonar. We use radar. वहाँ पे we use radio waves. They are electromagnetic waves. So they travel 1 million times faster than sound wave. So when it is not a very critical because ship sails at a very low speed. तो यहाँ पे sonar से काम चला सकते हैं. Ultrasound wave use करके. Because sonar equipments are cheaper. Radar will be costly. For military application, where time is critical, you have to use radar. Okay. So there are so many things to be told. Alright. So I wish you all the best and happy studying. Okay. If you have any doubts, you can call me back. Chalo, bye.
Yeah.